Next up, we have Dave Juntanen of Michigan DOT. Now, Dave is the bridge development engineer. He's kind of, I think, my counterpart in Michigan. But I think many of you know Dave from all of the involvement that he's had in a bunch of initiatives, at least since I've been involved in the past number of years in this. I see Dave on the landscape quite a bit with a lot of good input. Dave's been with Michigan DOT 28 years. He is involved on a number of AASHTO committees, T18, T11 as the chair, T8 also on the TSP2 oversight panel, and Bridge Preservation Expert Technical Group. So with that, please welcome Dave, and he's got some information he'd like to share with us for Michigan.
My presentation is called Prioritization of Preservation Needs, Michigan DOT New Methodology. That's what was shown in the agenda, and that's what I said I'd talk about. We went out for dinner and had a few drinks last night, and I come back and say, well, geez, I'm going to change this, and it's going to be called Fun with Deterioration Curves, but I decided not to. But it is, hopefully you might show how big of a geek I am, but you might see, you're going to see a lot of deterioration curves. Hopefully you find them interesting. Part of the national goals and performance measures that have been, going for the notice of proposed rulemaking and stuff, have, and MAP 21 have set requirements, that 10% of our bridges on the NHAS shouldn't be structurally deficient. The second one, which I have underlined, is state shall develop a risk-based asset management plan. I really haven't really seen exactly what that is, but there's a lot of information out there that both the Federal Highway Administration has provided in the past and other states and stuff that give some insight to that. And hopefully I'm going to show you our vision of that, what we do in Michigan. And, and then the terminology. We must maintain our bridges in a state of good repair. Now, this little chart here was provided when AASHTO SCOBS, I was on a sub-team where we provided some recommendations to the national performance measures. And, and if you remember, the measures that came out broke the bridges up into good, fair, and poor based upon the NBI. And that's actually really good news for all of us that are, in the preservation field, because that is talking about the fair bridges, or what we like to call at AASHTO, the fair bridges are your preventive maintenance needs. Your good bridges are your bridges in, good shape. All they might need is cyclic maintenance. And then once you become poor, it needs rehab and replacement. But since the FHWA, with these national performance measures, they're going to start talking about fair bridges too. That's really good news, because it's us managing those fair bridges. And that's what I'll be talking about a lot today. And this, of course, is just a bridge preservation guide. I think it's very well written. Anwar did a real nice job on that. But again, I show this here because I'm going to break this up into two categories, and this is how our bridge template in Michigan is. We have our rehab and replacement template where money is dedicated to those types of projects, and then we have a preservation or a preventive maintenance template where we do cyclic maintenance and preventive maintenance. And I'm going to talk a little bit about how we if you're doing good asset management, someday somebody's going to ask you, you can put the money in the templates and then you pick the projects, and somebody's going to ask you, well, what's your methodology for picking these projects? How are you picking them the right way so it's the most cost effective or what have you? And remember, MAP 21 said risk-based asset management. So to me, when you talk about rehab replacement needs, okay, risk-based fits in very, very well. And this is some of the things we do. We follow the guide to the vulnerability the vulnerability assessment for critical asset identification and protection. It's that was an AASHTO guide. I really like it, and it's where you start talking about your asset, its vulnerability and its criticality to the transportation system. And so each year we have a thing called our 5-year call for projects, where we're a decentralized state where we have 7 regions, but we control it centrally by giving guidance and setting goals each year with the regions. And so we write a call letter, and then the regions pick projects based upon the instructions there. And for our R&R program, one of the things that we require, and in the central office we help them out by all of our poor bridges over rivers right now, particularly this is an evaluation for scour, we will do an assessment, and it's a vulnerability assessment of that structure. So it'll get a score for vulnerability, which includes things like, okay, item 113 scour rating, the number of substructures in the water, footing type, skew angle, channel protection, soil type, scour mitigation, all these things, overall condition of the structure, all these things that show you, okay, is that structure at risk? And then the criticality score, okay, how critical that structure is to your system. And, for example, highway classification, the traffic volume, detour length, economic impact to the community. And so if a structure is rated both highly critical and highly vulnerable, our region has to say, why aren't you working on that? And so, it's really, prioritizing that those structures action is taken on to reduce its vulnerability. Okay, so that's how we prioritize, or partially how we prioritize our R&R program. Okay, now let's talk about, and in Michigan, 20% of our program goes to preventive maintenance. It has for years. Very much believe in it. It's been a tremendous help to us in slowing our deterioration rate, which I'm going to show you some charts on stuff. But how do you prioritize PM? That was a bit of a challenge because I really don't think it's a risk-based. It's more of how efficient can you be. And when you start doing preventive maintenance, I've seen other states have been seeing this too. I've got our number of bridges that are PM candidates or fair bridges shown here. As you do preventive maintenance, you start getting more fair bridges, so you start collecting them. So then, therefore, it becomes more important for you to do preventive maintenance. And so we've, in the last year or two, we've come up with some methods to help us prioritize our preventive maintenance. Now, I love to talk about Markov transition probabilities. It could be, this is where the geek in me starts coming out. This can be, it sounds overwhelming, it might be a little scary, but actually it's super simple. And the way we do it is just so easy. And I just want to take a little time to show you how we do it. It's simple counting, and we're doing it with the NBI. For example, in this slide here, I'm showing our 2009 and 2010 inspections. And I highlighted yellow our 5s because we're going to be talking about how we prioritize our 5 rated bridges for these PM projects. But our sample size is 904 bridges. Of those, 56 actually the condition state went up. So we're assuming we did a project, so we pull those out. Out of those 904, 879 when we inspected them in 2010 were still a 5. So our transition probability is 97.23% that it stayed the same. And so we can do the same thing about the probability, or we count the number of bridges that went from 5 to 4 and 5 to 3, and then we have corresponding transition probabilities there. Now, there's an equation. This is the toughest part of the thing, but just a simple equation that converts transition probability to the average number of years it takes to reach the next condition state. So 97.23 equates to 24.7 years. And so if you take your NBI scale and you do this for each one of those, on the next page, you produce a deterioration curve. And we've been doing this for years, and I just want to show you a number of different curves to show that intuitively these make a lot of sense. There's things you can do with these curves. One of the things we do is show our time to pour. Here I'm showing, the time from a structure being new until it reaches pour. In this case here is, you can't read that there, but that's 49 years. So it's in pavement in Michigan, I think in other states, they have a thing they call remaining service life. This is very similar to that. I like the term time to pour because we do have service life even once one of our major components of the bridge does become poor. I'm going to show you a few examples of how we've been doing with this. 5 years ago, and it's available on the internet, we have a report where we were curious to see how our reinforced concrete decks with epoxy-coated rebar was doing. We did that report in 2010. I was pleasantly surprised that we started doing epoxy-coated rebar in 1981. Could not find a single bridge deck surface, have you? Because we do both an NBI rating of the deck surface, the bottom surface, and an overall deck rating. The deck surface deteriorates the fastest. We couldn't find a single bridge where the deck surface had become poor. So that's good news, but our transition probability, or our curve, couldn't really extend beyond that point other than being able to draw a dashed line because we simply didn't have the samples after all those years. So we just repeated it this spring, and so in blue is 2010 and green is 2015. So there's two things that I find kind of cool here. One is the repeatability of using these transition probabilities to do this curve, because its 5-year average was like 2005 to 2010 and 2010 to 2015. Look how similar the curves are. And the good news for us, we still don't have a bridge deck with epoxy-coated rebar that has went poor. And I know there's the issues and controversies, and some in Florida and Virginia are saying dire things, but we're certainly not seeing it. So that's good news, but it's also a good use of this curve, which I really like. We are doing these curves for a whole bunch of things. I won't bore you by showing too many of them, but another one is for painted steel. We have a paint rating. It's an NBI 0 to 9 rating for the paint system on a bridge, and we find that the time to pour for painted steel beams is 23 years. Again, intuitive. It just, you look at that and say, yeah, that makes sense. I can believe that. Now for our three major elements, we've checked from 2000 to 2004, 2005 to 2009, and then 2010 to 2014. We drew these deterioration curves. Now here's the good news. This is more than anything, I think, showing the value of preservation, because you see a deterioration curve in 2000 to 2004 in red. Then in purple, 2005 to 2009, 2010 to 2014. As we've gotten better at preventive maintenance, our deterioration rate has clearly slowed, and that's really good news. I was really happy to see that. And this is something that we should continue to do. In fact, in Michigan, some of our priorities have changed a little bit, and we got some big mega projects that are kind of gobbling up all the money, and our PM program's taking a hit. So it'll be interesting to see in the next 5 years how it shows up in these curves. The same types of thing was done for our superstructure. We made quite improvement in our deterioration curve from 2000 to 2004, and it's been holding steady since in 2009 and 2014. And a similar thing for substructures. So again, super simple thing to do. Anybody who's got your NBI ratings can do this. We're happy to share our spreadsheets on how we do it. You'll find it's really quite easy. Now let's talk about management of our 5 rated bridges. These are our preventive maintenance candidates. Some people might call your 5 rated bridges your cusp bridges, because one of those major components, deck, super, sub, is close to coming into that pour. And again, as we built, and this is a chart actually for our Southwest region, but you can see in our Southwest region, as they built their PM program, they've collected a lot of 5s. And again, now it becomes important that we can't slack off on that. Now, here's how we developed a method for time to pour for doing prioritizing our PM projects. You can see our transition time for our 5s is about 24 years, shown right here. And so a bridge will linger in a 5 condition state on average for 24 years. Now, what we did, and it gets more complex than this because we took all the different types of decks, the different information we have, some of it being element level, and we're trying to make a determination of estimate how long it will take that particular type of deck to how long it will linger as a 5. And how you use that, for example, let's say you have a bridge that in 2005 it became a 5. And so in 2015, that's our current year, and then we know it's about 24 years before it become poor, so we can estimate for this particular bridge, you got 14 more years before it becomes poor. And so the estimated year the bridge will become poor is 2029. And so for each and every bridge that's rated 5, we have subroutines that will calculate the predicted poor year. And so in our call for projects, we give this information to our region bridge engineers, and then they can sort it, and they identify the bridges that are going to turn poor soonest, and they can prioritize their PM on that. And so, again, it's a tool for our region bridge engineers as part of the call for projects. You know, they follow our guidance in the call. We provide them the management tools, which I just showed you. But very frankly, that's just a tool they use. Another very big part on how they make good decisions is their personal knowledge of the bridges and inspector recommendations. Another thing we ask our bridge inspectors is if you're rating that bridge and one of those elements is on the verge of becoming poor, report it to the region bridge engineer, and they get it right on a list. Of course, you know, what's the value of prioritization? You know, it does steer you in the right direction, but the fact is when we do PM projects, we do them along corridors, you know, so we might do 10, 12 bridges. And of course, we are and always will be little brother to the road program. And so we need to coordinate, and you know, there's a lot of efficiency. If you got traffic control to take care of the roads out there, you're gonna go out there and you're gonna do PM on the bridges. And this is an example again of our Southwest region. What they provide as part of the call for projects is they count up their bridges that are poor, and then the predicted ones that are going to become poor based upon the tools that I've had. And then they do evaluation on what they can do with these, which ones they just can't get to, and in the end, at the end of the call for projects, they show us what the end outcome is from their program. Now, what I really like about this program is all of our region bridge engineers come into the central office. They do a report that they hand to us. That's their call for projects and selection of the bridges. And the coolest thing we do now, it's not reviewed by me. I don't even review it anymore. It's reviewed by their peers. It's the other region bridge engineers. And you should see the really good conversations that they have and how much they learn from each other. So with that, I'm going to brag a little bit. This is our Fort Street Bascule Bridge. We just lifted it for the very first time. It's under construction last week. I'm not so sure, but I'm told it's the largest overhead counterweight single span bridge in the nation, but a lot of stress wondering if it's going to open when the Coast Guard said we had to have it open. And finally, I want to give special thanks to Bob Kelly, who's our bridge systems management engineer and the real genius behind almost everything we do. Bob's not a big one for getting up here and speaking, so I tend to take all the good stuff he does and come present it. But thank you, Bob. And with that, I'll be happy to answer any questions.
David, that was a good presentation.
Thank you.
Those charts looks like they're based on MBIS. So did you find a way to convert them to element inspection yet? Or?
Oh, well, we do similar charts, and you know, of course, the AASHTO bridge management software is going to be doing this very soon. But we do similar charts using element levels. It's a little bit more challenging for some of the elements. Like, I find it's easier to do these types of things when the quantity's each, but when it's lineal foot, it's just a little bit more challenging, but very doable. And we do those charts too.
But it still is based, condition-based, looks like it, not data-based. Is that fair statement, or?
It's condition-based versus what?
Data-driven.
Well, the condition is data. I mean, you know, that's the best data I think we have.
No, what I'm saying is, did you get into it to get the risk? Is there any risk assessment there, or?
Well, the risk assessment, I showed you what we do is part for our R&R program. And they get a score, and if it's rated highly critical or highly vulnerable, then it moves up on our list of projects.
Hey, David, that was a good presentation. I'd like a copy of that if you can give me that. That's
You're welcome to it, yeah.
But the one quick question to follow up with what he was talking about is, this is good to be programmatic level, to be able to figure out what funding we need. But once you have the funding, I guess you really need to figure out what action to do on what bridge. You need additional data at that point? Because this is based on NBI?
That's an excellent point. And the question was, okay, you know, this was kind of determination and need, and how do you get down to the details? We have, for years, every project we do, and we spend a fair amount of money at this, we do a detailed scope. So you have the NBI inspection, and we are a Pontus state. We have our brand new national bridge elements, and we're really excited about that. Even with both of those, okay, all we do is we determine it's going to fit in this category, and then we detailed scope it. And the detailed scope will be a chain drag of the bridge deck, maybe thermal imaging, maybe coring. It's definitely always measuring the section loss at the beam ends. And then there could be life cycle cost analysis with it. I'll be happy to share with you reports that we do. Consultants love it because, well, they've told me, he said, Dave, that's easy money for us to do this. But it gets you off to the right start with the project because, you know, it fine tunes and details and brings you right in, and moving out to your, you know, to your study stage, you've already done a lot of the work. So it's a very good point. You know, this presentation doesn't get into, you know, how we determine fixes at all, but detailed scopes are so important.
So you guys are doing national bridge elements now, and you were doing core elements.
Yeah.
Obviously, the big one is deck has changed dramatically as far as just the whole philosophy on inspecting and recording decks. Have you guys come up with a way to take the information that you've gathered for the past, whatever, 15, 20 years, however long you've done core elements, and somehow translate that into the new national bridge elements so you have deterioration curves for those?
No, we're not even going to worry about it. And that's kind of a funny statement because we've been collecting, you know, the original core elements since '95, and we've drawn deterioration curves. And our primary use of the element level data is Bob Kelly is told to produce a report each and every year, and in that report he uses national bridge element information to do I think 2 or 3 things. One is identify the needs for that bridge in more detail that I'm showing here, and estimate the cost. And so our region bridge engineers also get that information. Now, due to the limitations of the core elements, it was of limited value. We've kind of reached a plateau of what we could do with it. Now that we've updated to the national bridge elements with a lot of our own information to improve that, we're very excited to wait to find out how we can do that. But it'll be the same thing. To me, the national bridge elements is more detail on what you're going to do, particularly for PM, because we could adjust how we do detailed scopes if that information is good. We're just in the collection stage yet, so you know, we'll look at our business process in the future on the value of those national bridge elements. But to me, it's going to be the very same thing: is more detail what you do at the bridge and how much it's going to cost.
Yeah, the thing that I see is, I mean, it's probably going to be 3, maybe 4 cycles before you really have enough information to be able to really get conclusive deterioration curves for any of those elements. So I was just curious how you guys were handling that.
Yeah, and you know, to be honest with you, when you start deteriorating, we're pretty happy with the NBI information for the 3 major components for deteriorating the bridges. Mm-hmm. All right, thank you.
All right. Thank you, Dave. That was an outstanding presentation.